Back in the beginning of the chapter, I did say that there would be 3 ways we could use matrices to solve a system of equations. Okay? Here is the third. It's called Cramer's rule. Cramer's rule is a way for us to use determinants to solve a system of equations. Okay? We cannot use this rule if the determinant is 0. That's because we are using fractions and we can't divide by 0. Okay? So, this method is going to apply to a system no matter how many variables there are. So what I'm going to do is I'm going to show you how you solve for x, and then you are just going to apply these steps for y, z, w, however many variables you have. Yes?
So, is it possible to go the other way, like with determinants? Can you know the determinant and then go backwards and find the matrix?
There are a lot of different matrices that would have the same determinant, so there would not be a unique solution. Does that make sense?
Yeah.
Okay. Okay, so for each solution, you're going to have a determinant over a determinant. Okay, those D stand for determinant, but one of them has a subscript of x, specifically for when we're solving for x. Okay, and remember, if we're solving for y, we're just going to change these to y's. Okay, so what do these D's mean? D, without a subscript, is the determinant of the coefficient matrix. Okay, so take all of your coefficients, make a square matrix, find its determinant, that's D. Okay, now I'm going to let you write down what D sub x means, and then once we have it written down, then we're going to talk about it. What's not that many words? You guys can. So what's going to happen is we are going to make a matrix with the coefficients, but we're going to replace the x column with the constants. Okay? So you know, so what I mean is our coefficient matrix would be 1, 1, 2, 1, right? Well, if we go here to find the determinant of x, then we're going to take the x column and we're going to replace it with 3, 4. Okay? Then we would have a different matrix to find the determinant of. If we were solving for y, then we would do the same thing, but we would replace the y column with those constants. Okay? So we are going to practice this with a 3-variable system. Okay? So that you can see the pattern. And I'll use different color pens so you can see what is changing where. All right? But essentially, for our numerator, that matrix, you're going to replace whichever column you're solving for with the constants. Okay? So go ahead and write down this system so that we can talk about what everything is. Okay? So let's first talk about the determinant of the coefficient matrix. Okay? If we were to create a matrix out of just the coefficients, what would our first row be? Good. Our second row?
2, 0, 1.
Good. And our third row?
3, -4.
Good. Thank you, Lindsay. Okay. For Cramer's rule, we need the determinant of that matrix. So I'm going to give you the opportunity right now to find that determinant. Birdie from Pod 3 told me that they got 10. If you did not get 10, compare your work to a neighbor so you can see which multiplication maybe you messed up on. Okay, so your work should be 0 plus 6 plus 24, correct? Minus 0 plus 4 plus 6, 18. You want to finish? You get 10. We tried a mistake? I'll tell you that. Was it a negative that you missed? Okay. All right. So that is going to be the denominator for each fraction that we set up. Okay? When we go to find x, we are going to take d sub x over d. Okay, so what does that mean? We are going to find the determinant of the matrix when the x column is replaced with these numbers right here. These that I'm circling in green, those are the constants. They're on the other side of the equal sign. So 1, 0, 2 is your x column, and then your y column and your z column will remain the same. Okay? And your denominator we found to be 10. Don't start finding this yet. I want to set all of these up first, and then we're going to divide and conquer. Okay? For y, we're going to take d sub y over d. What does that mean? That means the matrix that we have in our numerator, we're taking the constant 1, 0, 2, and that is going to be our y column since we're solving for y. Our x column is going to remain negative 1, 2, 3, and our z column will remain negative 3, 1, 4. And we're still dividing by 10. Okay. And then to solve for z, same process, except now our numerator determinant, we're going to put our constants 1, 0, 2 for the z column, and our x column will remain as negative 1, 2, 3, and our y column will remain as 2, 0, negative 4. We'll divide by that determinant of 10 that we already found. Okay. So to save time for the rest of the lesson, I'm going to ask pods 3 and 4 to find me d sub x. I'm going to ask pod 2 to find d sub y, and pods 1 and 5 to find d sub z. So we'll each do a 3 by 3 determinant. I just won't make you do all 3 by hand today in class. Go ahead and compare answers with your neighbors. Make sure you're getting the same thing. All right, pods 3 and 4, what are we getting for that determinant? What did you get for the determinant?
8.
You got 8 for the determinant. So we have 8 over 10, which Eli has reduced to 4/5. Okay? Pod 2, what did you get for d sub y? Negative 15. So we have negative 15 over 10, which is negative 3/5. I don't even know what I was negative.
3/2.
That's what that is. Okay. Pods 1 and 5.
We got negative 16.
let's remember that we are solving a system of equations. So your answer would be the coordinate 4/5, -3/2, -8/5. Okay, let's talk about the benefits to this method. When we do algebra, when we have fractions, is it messy? It's messy, okay? If we are doing row operations to get an augmented matrix into row echelon form, are fractions messy? Oh, you betcha they are, okay? Here, do we really have to worry about fractions during our work? We don't worry about fractions until the very end. Now, you have to find 4 3x3 determinants, but it's going to make, if your answers are fractions, makes it easier. Okay, so there's benefits, there's pros and cons to all the ways we know how to solve systems. Okay, I will tell you, you need to practice this, but there will be a little bit of choice involved in the test on Tuesday. I'll give you more details on Monday, but you will need to know how to do Cramer's rule for sure. Okay. All right, so there's one way we can use determinants to help us. I like Cramer's rule. I think it's a nice way to solve systems of equations. Okay, you can solve 2x2 systems with these, and how easy are 2x2 determinants to find? Pretty easy, right? So you're going to solve some 2x2 systems in your homework. Those should be pretty quick problems. Okay. All right. As it turns out, we can find the area of a triangle. Okay, some of you are like, I'm going to put a screenshot up here. Some of you are looking at this like, oh my gosh. Okay. We can find the area of a triangle. Okay, now let's think about it. If we have a triangle in the coordinate plane, how do you guys know how to find the area of a triangle? ½ base times height. Well, if you have a triangle that doesn't have a right angle, that one doesn't have a right angle. It's not very convincing, though. Okay. If we have a triangle that doesn't have a right angle, and its base isn't like parallel or perpendicular to an axis, finding the base and the height can sometimes be tricky, right, in a coordinate plane. Okay, so what we can do is we can actually use a determinant to help us find the area of a triangle without us having to do some messy geometry to figure out the base and the height. Now, if your triangle is sitting on the x-axis or parallel to it, we can easily find the length of the base and the height just by counting, right? But if it's not parallel or perpendicular to the x-axis, then we have to do some messy geometry, and not always is it easy. So here is a way to take 3 points in a coordinate plane and find the area of a triangle. So I'm going to let you just write it down, and I'll talk about how we're going to use it. So what's happening is we have a 3x3 determinant where you're going to put your coordinates in the x and y column, and then your third column would be a column of 1s. So x is in the first column, y is in the second column, 1's in the third column. But make sure that your ordered pairs are paired together in the same row. Okay? So this means we're taking 1/2 times the determinant. Now, why is there a plus or minus out front? you can get a negative determinant, and why would that be a problem? We can't have a negative area, okay? So basically what this means is if your determinant is positive, keep it positive. If your determinant is negative, multiply by a negative, make it positive. Okay, because we have to have a positive area. Okay, we have to. Okay. So please go ahead and write down these three coordinates, and then we're going to find the area of the triangle. So our coordinates are 1, 0, 2, 2, and 4, 3. So area equals plus or minus 1/2 times the determinant. What we're going to do is we're going to put 1, 0, 2, 2, and 4, 3 at the beginning of our rows, and then a column of 1s. Now it actually does not matter which rows are which. It only matters that your XY coordinates are together in the row. Okay? You cannot multiply by 1/2 until the very end. So let's find our determinant first. So our area is plus or minus 1/2 times. Okay. Help me out. Our first diagonal is 2 plus 0 plus 6. And we're going to subtract the up diagonals. 8 plus 3 plus 0. Okay, so help me out. We have 6 plus 2 minus the quantity 8 plus 3. What is that? What did you say? Negative 33. 3. Okay, so which 1/2 do we need to choose? We need to choose the negative 1/2. Okay, we're going to multiply by the negative 1/2 so that our area is 3/2. Now, if there are units attached to it, we know that this would be a square units type of measurement because it's area. Okay, but area does have to be positive. So you choose either the positive or the negative 1/2 based on the value of your determinant. Now, I want you and your pod to have a discussion about what would it mean if we set this up with 3 coordinates and the determinant was 0. Talk about it with your pod. All right. What do you think? What would it mean if we set this up and the determinant was 0? Hey, it's not a triangle. More specifically, what would be true about our 3 points? If it's not a triangle. If 3 points don't make a triangle, they make a line. Okay? So if you put 3 points into this determinant and it is 0, that means your 3 points are collinear. Meaning they lie on the same line. That matrix you see is the same as the slide before, except without the plus or minus 1/2 in front of it. So if I present a question like this, are the points -2, -2, 1, 1, and 7, 5 collinear? If I present this question to you on a matrix test, what would you do to solve it? Throw it into that determinant. Okay? So you have these coordinates written down. Okay, what I would write in my notes are those 3 coordinates in collinear ? So you know what we're testing for. I'll put in the 3 coordinates with a column of 1s. All right, do you agree with all my products there? So what is the value of this determinant? What's the value of this determinant? Thank you. So how do we answer our question? No, these are not collinear because the determinant is not 0. What did you say, Isaac? Eli? What did you say, Eli? Okay, the area of the triangle that these 3 coordinates would make would be 3. That would be accurate. So what if I presented you with this problem? Now I know we all know how to do this, but go ahead and write it down. And I want to show you a way to do this with matrices. I'm going to come back to here. If 3 points are collinear, we put those 3 points in this matrix, and they should equal 0. If we want to write the equation of a line with 2 points, how do we do that? Do you think we can use that same idea? Probably. Okay. We know that the determinant should equal 0 if we have collinear points. Okay. So what we're going to do is we're going to pick a generic coordinate. X, Y, and then our 2 coordinates 2, 4, and -1, 3. Okay. Why did I pick the generic coordinate X, Y? First of all, we're writing the equation of a line, so we need an X and a Y. Second of all, we need 3 coordinates to fill in this determinant. Okay, so I just picked a generic one, X, Y. Okay, so now watch what happens. So we know that this needs to equal 0, right? So now we can find the determinant But now when we find the determinant, our products could have an x or a y in them, and that's okay because we are writing the equation of a line. Okay? So we have 4x plus negative y plus 6 minus our up diagonals, negative 4 plus 3x plus 2y. That's the value of our determinant, and since we want these points to be collinear, we know that the determinant should equal 0. Okay, so now it's a matter of combining like terms so we can write the equation of our line. So what is 4x minus 3x? X. What is negative y minus 2y? Negative 3y. And then we have 6 minus negative 4. Okay. We see lines written in two different ways. We either see ax plus by equals c, or we see y equals mx plus b. Do not solve for y equals mx plus b. It is fine to leave it in the standard form where you have ax plus by equals c. This is just fine. Negative 10. Thank you. I thought about it as soon as you raised your hand. Yeah. You can, it's just more work. This is an acceptable form of the equation of a line. So it's okay to just stop here instead of doing slope-intercept form. Okay. All right, so we have 10 minutes left in class. What I'd like you to do is I'd like you to start your assignment, see if you can get at least one problem, if not two, done before you leave. That way you just have a chance to practice something. You don't have to do the first problem. Maybe you want to do a linear problem. Maybe you want to do an area problem. Maybe you want to do Kramer's rule. I don't know. But pick a problem or two from your homework to try before you walk out that door.